In this session, we will discuss about J.J. Thomson model of atom, Rutherford atomic model and its limitations, atomic number and mass number. The postulates of Thomson's model of atom are: an atom consists of a positively charged sphere with electrons embedded in it. Second point, an atom as a whole is electrically neutral because the negative and positive charges are equal in magnitude. Thomson's atomic model is compared to a watermelon, where he considered watermelon seeds as negatively charged particles and the red part of the watermelon as positively charged. According to this model, an atom is a sphere of radius 10 raised to minus 10 meter with uniform distribution of mass and positive charge. The negatively charged particles called electrons are embedded within it. In this model, the negatively charged particles called electrons embedded in an evenly distributed positive charge can be visualized as plums, raisins or seeds that are embedded within a pudding or watermelon. Therefore, this model is also called plum pudding, raisin pudding model or watermelon model. Later, Ernest Rutherford, the student of J.J. Thomson, proposed the Rutherford model of atom based on his gold foil experiment. The famous experiment of Rutherford was the alpha particle scattering experiment. In this experiment, a stream of high energy alpha particles from a radioactive source was directed at a thin foil of gold metal. The thin foil had a circular fluorescent zinc sulfide screen around it. Whenever alpha particles struck the screen, a tiny flash of light was produced at the point. We will now watch the gold foil experiment conducted by Rutherford, his observations and his conclusions about the model of atom based on this experiment. In this experiment, a stream of high energy, positively charged alpha particles from a radioactive source was bombarded on a gold foil. The very thin gold foil had a circular fluorescent zinc sulfide screen around it. Whenever the alpha particles struck the zinc sulfide screen, a tiny flash of light was produced at that point. Now we will discuss the observations of Rutherford's alpha particle scattering experiment. The observations are: first, most of the alpha particles passed through the gold foil undeflected. Second observation, small fraction of the alpha particles were deflected by small angles. Third observation, few fraction of alpha particles were deflected by large angles. Fourth observation, very few alpha particles like 1 in 20,000 bounce back to the source by 180 degree. We will now discuss the conclusions made by Rutherford based on his alpha particle scattering experiment. As most of the alpha particles passed through the gold foil undeflected, he concluded that most of the space inside the atom is empty. Since a small fraction of the alpha particles were deflected by small angles, he concluded that there must be a positively charged species at the center of the atom based on the fact that only a positively charged species can repel the same positively charged alpha particles by small angles. Since a very few fraction of the alpha particles bounce back, he concluded that the positive charge is concentrated in a very small area at the center of the atom. To summarize, the results of the experiment are: most of the alpha particles passed through the gold foil undeflected. A small fraction of the alpha particles were deflected by small angles. A very few alpha particles, 1 in 20,000, bounced back nearly by 180 degree. The observations of this experiment are: most of the space in the atom is empty as most of the alpha particles pass through the gold foil undeflected. A few positively charged alpha particles were deflected. This deflection must be due to enormous repulsive force of the positive charge in the atom. The positive charge has to be concentrated in a very small volume that repelled and deflected the positively charged alpha particles. The conclusions made by Rutherford based on this experiment are: the positive charge and most of the mass of the atom was densely concentrated in an extremely small region. This concentrated region was called the nucleus. The nucleus was surrounded by electrons moving in very high speed in circular path called orbits. The electrons and the nucleus are held together by electrostatic force of attraction. Now we will discuss the drawbacks of Rutherford model of atom. A body while moving in circular motion will undergo acceleration. On undergoing acceleration, it should use some energy. So the energy of the electron should keep on decreasing. As a result, the path in which it is moving should become smaller and then finally fall back into the nucleus, and hence the atom should collapse. So, the nuclear model could not explain the stability of the atom, and this was its major drawback. The drawbacks of Rutherford model of atom are: it could not explain the gravitational force in nature. It could not explain planetary motion under the influence of gravity. It could not explain Maxwell's electromagnetic radiation property. Also, it could not explain quantum mechanics as a whole. Now we will discuss about representation of an atom and atomic number and mass number. The representation of an atom is shown here. The symbol X represents the symbol of the element. The superscript A represents the atomic mass number, whereas the subscript Z represents the atomic number of the element. The atomic number Z gives the number of protons present in an atom, whereas the mass number A gives the total number of protons and neutrons present in an atom. We will now discuss a simple question based on this. An atom has 29 electrons and 35 neutrons. Calculate the number of protons and the mass number of the element. Also write the complete symbol for the atom. In a neutral atom, number of electrons and number of protons are equal. So in this question, the atomic number Z, which is equal to number of protons, is also equal to 29. The mass number is given by total number of protons plus total number of neutrons. As per the details, it is given by 29 plus 35, that is equal to 64. Now since the atomic number is 29, the element is copper. In a neutral atom, number of protons and number of electrons are equal. The number of neutrons is given by mass number minus atomic number. We will now find the number of protons, neutrons and electrons in some elements. The first element is bromine. Here we can see that the mass number is 80 and the atomic number is 35. Atomic number 35 means number of protons is equal to 35, which means that the number of electrons are also equal to 35. Now, the number of neutrons is given by mass number minus atomic number, that is 80 minus 35, and the answer is 45. The next element is chlorine. The mass number is 37 and atomic number is 17. Since the atomic number is 17, the number of protons is equal to 17, which implies that the number of electrons is also equal to 17. Now, the number of neutrons is given by mass number minus atomic number, that is 37 minus 17, and the answer is 20. The next element is fluorine. The mass number is 19 and the atomic number is 9. Since the atomic number is 9, the number of protons is equal to 9, which in turn, the number of electrons are also equal to 9. Now, the number of neutrons are given by mass number minus atomic number, that is 19 minus 9, and the number of neutrons is equal to 10. Next, we will discuss how to find the number of protons, neutrons and electrons in case of ions. Ions are of two types, cation and anion. Cations are positively charged species, whereas anions are negatively charged. Here the ion given is sodium plus 1 cation. A cation is formed by the removal of electrons from a neutral atom. Since the charge given is plus 1, this means that this ion is formed by the removal of 1 electron. The mass number is 23 and the atomic number is 11. Since the atomic number is 11, the number of protons is also equal to 11. If it was a neutral atom, the number of electrons also would have been equal to 11. But in this case, here it is sodium plus 1 cation, that is 1 electron is removed. So the number of electrons is equal to 10. The number of neutrons is given by mass number minus atomic number, that is 23 minus 11, and the answer is 12. We will solve a few more similar questions. Now, we have to find the number of protons, neutrons and electrons in each of these ions. The ions are potassium plus 1 cation, oxygen minus 2 anion, and calcium plus 2 cation. In the case of potassium, the mass number is 39 and atomic number is 19. Since the atomic number is 19, the number of protons is also equal to 19. If it had been a neutral atom, the number of electrons would have also been equal to 19. But since it is an ion and the charge is plus 1, this means that one electron is less compared to the number of protons. So, the number of electrons is equal to 18. The number of neutrons is given by mass number minus atomic number, that is 39 minus 19, and the answer is 20. Next, in the case of oxygen, the mass number is 16 and the atomic number is 8. Since the atomic number is 8, the number of protons is equal to 8. If it had been a neutral atom, the number of electrons would have also been equal to 8. But in this case, the charge of oxygen is minus 2. It indicates that there are 2 electrons extra when compared to the number of protons, so the number of electrons is equal to 10. Now the number of neutrons is given by mass number minus atomic number, that is 16 minus 8, that is equal to 8. Next, in the case of calcium, the mass number is 41 and the atomic number is 20. Since the atomic number is 20, the number of protons is also equal to 20. Now the charge of calcium is given as plus 2. A charge of plus 2 indicates that there are 2 electrons less when compared to that of the number of protons. So the number of electrons is equal to 20 minus 2, that is equal to 18. Now the number of neutrons is given by mass number minus atomic number, that is 41 minus 20, and that is equal to 21. Now as a homework, write the nucleus symbol for the following atoms or ions with the help of a periodic table and also mention the charge of each atom or ion.